Right now, you're on planet Earth. You've been trained and fully prepared for your mission today. The final touches are being made on the massive spacecraft that's going to take you all the way to the planet Jupiter. You've just taken your first small step on this long journey, and now you're in space, orbiting Earth. The first thing you need to consider on your mission is the incredibly long time you'll be spending inside your spacecraft before reaching Jupiter. That's because the average distance between Earth and Jupiter is around 440 million kilometers. That's roughly 273 million miles. Travel time could take up to 5 years. But for example, the Voyager 1 spacecraft passed by Jupiter in about 1.5 years. That's because its final destination was way beyond Jupiter. It just flew by really fast. But if your actual target is Jupiter, you'll have to arrive slowly enough to enter a stable orbit around the planet. If you arrive too fast, you'll just pass by it and won't be able to stop. So, let's get back to your journey. After 7 months of travel, you'll pass by a familiar object that'll keep you company for a little while on this long, lonely trip: Mars. After that, you'll spend a full year until you reach the next closest thing after Mars, the asteroid belt. Passing through it could be smooth and easy, or chaotic and terrifying. Then you'll spend over 3 more years traveling through the empty, quiet, dark space. And after this long, exhausting journey, you'll finally reach your destination. Now comes the part everyone's been waiting for. You'll take one last look at Earth to comfort yourself before starting your descent into Jupiter. You activate your advanced spacesuit and begin your dive into Jupiter at 250 kilometers in, about 155 miles. You'll enter the planet's upper layers, made of ammonia clouds. You'll still be able to see sunlight, but unfortunately, it won't help you much. Temperatures here reach minus 150 degrees Celsius, or minus 238 degrees Fahrenheit, and the pressure is about half that of Earth's. After about 15 kilometers, roughly 9 miles, of descending through the ammonia clouds, you'll reach the second atmospheric layer, dark brown clouds made of ammonium hydrosulfide. At this point, sunlight will look like sunset on Earth. The air pressure is climbing, and of course, the winds are getting extremely intense, reaching speeds of over 480 kilometers per hour, about 300 miles per hour. Jupiter spins faster than any other planet, completing 1 full rotation in just 9 Earth hours. And the deeper you go, the darker and more pressurized everything gets. It's like diving into the ocean. By the time you reach the end of the second layer, everything around you will be pitch black. Then, you'll enter the third atmospheric layer, composed of white water clouds, similar to those on Earth. The only light source now will be lightning bolts, 1,000 times stronger than lightning on Earth. But luckily, your high-tech suit comes with all the latest features. You switch on night vision to see what's around you. At this moment, you're now experiencing pressure levels of 5 Earth atmospheres, and the temperature has risen to a comfortable 20 degrees Celsius, about 68 degrees Fahrenheit. But after the third layer, everything changes fast. Pressure jumps to 10 atmospheres. Temperature skyrockets past 200 degrees Celsius, about 392 degrees Fahrenheit. As you go deeper, Jupiter's atmosphere becomes incredibly dense. You'll feel like you're swimming through liquid, not falling through gas. This happens because the material around you has reached what's called a supercritical state. It's a strange phase where matter is caught between being a gas and a liquid due to extreme temperature and pressure. And as you descend even further into this strange substance, both pressure and temperature increase dramatically. The darkness begins to fade, not because it's getting brighter, but because everything around you is glowing with intense heat. You pull down your suit's light shield just to see clearly. Now, you're diving into a massive ocean of liquid metallic hydrogen. This is what gives Jupiter its powerful magnetic field. At this point, you've traveled over 500,000 kilometers, about 310,000 miles, into Jupiter's depths. The atmospheric pressure here has reached 2 million Earth atmospheres, and the temperature is now over 10,000 degrees Celsius, about 18,000 degrees Fahrenheit, which is nearly twice as hot as the surface of the sun. You'll keep sinking in this bizarre material for a long time, until finally you reach the planet's core, estimated to be 10 times the mass of Earth, made entirely of rock and exotic molten ices. Here, you'll be standing on a solid surface with a pressure of 25 million Earth atmospheres and a temperature over 30,000 degrees Celsius, about 54,000 degrees Fahrenheit. And at that moment, after everything you've just experienced, you'll realize the best way to observe Jupiter is from outside the planet, or maybe from one of its moons, like Europa, for example, which scientists believe holds massive oceans of water beneath its icy crust, oceans that could even support life. Of course, everything we just described is based on scientists' best estimates, because the only spacecraft that ever entered Jupiter's atmosphere couldn't get more than 370 kilometers, about 230 miles, in before being completely destroyed by the crushing pressure and extreme winds. That spacecraft was Galileo, launched from Earth in 1989, and it reached Jupiter in 1995. It spent 8 years studying the planet and its moons until it dove into Jupiter's atmosphere in 2003 and was torn apart. It was named after the legendary astronomer Galileo Galilei, the man who first discovered Jupiter's 4 largest moons. And so, the true nature of what lies deep inside Jupiter remains a mystery, a strange world, still hiding its secrets beneath a thick, swirling sky.